So for descriptive stats, the tough stuff, I'm going to go through these 9 multiple choice questions. Remember question 10, I told you to answer A for those who paid attention. And then we're going to go over these 2 free response parts down here. That is a free response, and some of you didn't realize it. I don't know what you're paying attention to, but let's go ahead and go through this. Okay, ignoring this, we're looking at which is true for the construction of a bar graph. Has to be true. The scale of the horizontal axis should be the frequency. No, that's our independent value that normally goes down there. There are no gaps between the bars. Well, yes, on bar graphs, there are gaps. Histograms like this, frequency distribution on this is no. Bar graphs are used to depict categorical data. There we go. There's my answer. I don't need to go any further. I can go ahead and talk about the others. But bar graphs are used like circle graphs, and segmented bar graphs are used to depict categorical data. All right, mention the shape center spread should be made when describing bar graphs. That's not that big of a deal. The width of the bars should differ according to the frequency of the class. That's definitely no. You want consistency with your spacing. So the answer to number 1 is C. Answer to number 2, I'm not even going to dwell on. I had people that told me that that's supposed to be 50, and then I asked a couple of other people who online have used this, and they said, no, that's supposed to be 75, that this is 50. So that question I'm just tossing. I'll go in and add a point to people's scores, but if you missed that one, I'm not even concerned about that one anymore. That's such an ugly question. But let's flip over and go on. For this third question, the box plots shown above summarize 2 data sets, set 1 and 2. It's based on the box plots. Which of the following statements about these 2 sets cannot be justified? This was an actual AP question. Okay, I have no idea what all that is. I don't know that those are outliers. I've just noticed those for the first time. I think that's a misprint along the way because it wouldn't be shown as those dashes. But anyhow, we'll keep going. The range of the data set 1 is equal to the range of data set 2. This cannot be justified. If we look at that, sure, it is. Those are the same length. The interquartile range of data set 1 is equal to the interquartile range of data set 2. So this goes from 35 to 50, which is 15. This goes from about 30 to 45, which is 15. So both of these are true statements. The median of data set 1 is less than the median of data set 2. Well, here's data sets 2 median. There's data sets 1 median. So that is also a true statement. Data set 1 and data set 2 have the same number of data points. We have no idea. This isn't showing how many points are in there. This is showing the comparison of the spreads and the grouping, the variance of our data points. So this is not true, but I'm going to go ahead and look at E anyhow. About 75% of the values in data set 2 are greater than or equal to about 50% of the values of data 1, 50% being the median of data 1, which is here. And sure enough, that matches up with the first quartile. 75% of this matches with 55. So this is also true. So the answer on number 3 was D. Number 4, which graph would have the smallest standard deviation, which is the average distance from the mean, if the vertical axis of each graph uses the same scale? So the average distance from the mean, this is roughly symmetric and unimodal. So the average distance here would be smallest. This is great. This is called a uniform distribution. No, this, as a matter of fact, when I ran this, this was the average distance, I think, was something like, oh golly, what was it, Pruitt? 3.7. And then just if I randomly made up some numbers and said these heights were all 5 or 4 or whatever they were, where this one, the average distance from the mean, which the mean is here because it's in the median, because it's roughly symmetric, they're really close together. This distance, but there's a few of those that are far away, fewer still that are closer, and then a vast majority are real close. This one would have the smallest standard deviation. This one, since this is skewed to the left, my median's probably somewhere in here. My mean is pulled this way. So there's a lot of them up here that are pulled, that are far away. Some here, but that distance is short, but there's a bunch here. This one is just the opposite of this. My mean and median are probably here, or very close to this. And there's a lot of values that are real far away from it, not many in the middle. So this B makes the most sense. It would have the smallest standard deviation. Okay, number 5, the company wanted to determine the healthcare cost of its employees, so it took a sample of 25, and it later discovered the highest medical expense in the sample was mistakenly recorded as 10 times the actual amount. However, after correcting the area, the corrected amount was still greater than or equal to the other medical expenses in the sample. In other words, this maximum value was still the maximum value. So which of the following sample statistics must have remained the same after the correction was made? Well, there's 25 numbers. That's an odd amount. So my mean definitely got smaller. My standard deviation got smaller. My range decreased, and the variance, which is a square of the standard deviation, also got smaller. The median had to stay the same because the highest number stayed way over here on the right. If I have all these numbers listed out here, if I've got a bunch of numbers listed here, 2, 4, 6, 8, 10, 12. We'll just go 13 for right now. I'll put 14 there because we have one that's way out here away from everything. Well, if it turns out that number was wrong, but it was really here, then that decreases the mean, that decreases the standard deviation, range, and variance, but my middle number is still my middle number, wherever it is amongst 3, 6, 7, 3, 6, 7. Yeah, this number is still going to stay my median. So the median does not change. Okay, for number 6, we've got these ugly looking graphs. Looks like something I would draw. For which of the following distributions is the mean greater than the median? Okay, this is uniform. They're pretty much going to be the same. This is roughly symmetric. They're going to roughly be the same. This is bimodal, but also roughly symmetric. This is also going to be about the same. So it's going to be one of my two skews. This one is skewed to the right, and the farther you go to the right, the bigger the numbers get. So this would be where the mean is greater than the median, because when data is skewed, the median is probably somewhere in here, but the mean is being skewed away from the median. So that answer for number 6 is A. Number 7. This is going fairly quickly, still 8 minutes in. Okay, number 7, a frequency distribution with a mean of 100 and a median of 90 is, okay, so if we make a picture, and right here's my median, and right here is my mean, which is at 100, okay, which is farther over. This is 90, this is 80, this is 100. So what does that probably mean? That the graph is skewed to the right. I just discussed that it's probably skewed to the right, that it's being pulled down to the right. So that is positively or right skewed. Suppose a frequency distribution with a range of 0 to 100 is positively skewed. The greatest frequency, so it's from 0 to 100. So let's make a picture. So there's 0, there's 25, there's 50, there's 75, and there's 100. Okay. And it says it's positively skewed. That means most of the data is here, and it's skewed this direction. That means most of the data could be expected to be around A, 25. We expect most of it to be down here. It's skewed to the right. That means we have a bunch of we have large numbers, but in small quantity. We have a large quantity of numbers around 25. That would make sense to us. If it was around 50 and the numbers go from 0 to 100, we wouldn't expect this look. But to be positively skewed, we'd expect the vast quantity of the numbers to be around 25. The mean is somewhere this direction because it's skewed to the right. Okay, number 9, the median of a distribution is 150. So let's draw us a number line here. The median is at 150. The interquartile range is 50. All we know is that we have a box plot. We don't know what that box plot looks like, but the median is here. The interquartile range is 50. So which of these statements must be true? Well, this says 50% of the data is from 125 and 175. If the interquartile range is 50, that means 25 on each side of that if it were balanced, but it doesn't say it's balanced. We do know that 50% of the data is less than 150. That's a true statement. I mean, because we could have an interquartile range that looked like this. Most of our data is gathered right here in this area. And then we have our box and whiskers here. Our median is right here, but that is that. And it says 75% of the data is greater than 125. It never tells us what the first quartile is. We cannot make that guesstimation. The only one that's true is B. That's the only thing that could be true. These might be true, but there's nothing that says they have to be true. And the point here was must be true. This must be 50% of the data falls below 150 and 50% is above 150 because it's the median. So the answer to that is B only. All right, down here on our graphs, the box plot represents the points scored of the top 6 players on a championship basketball team. Using the diagram, answer the questions below. Which player is the best on the team based on his shooting record, and explain why? Okay, the best player is Duncan Dave. Dave had a bad game here, but that's not that big of a deal. This is, and I told y'all the median does not matter on this if y'all paid attention to me when I first assigned this. From here up is 75% of his data. No one comes close to scoring 75% of his points or up from there. Steve Sky has such a wide variance. I mean, there are times he scores from 1 up to 24, which is 1 or 20. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So 27 is really right there. So Dave had a game where there was a Steve Sky, 25% of his time he scores way up here, but Duncan Dave is the most consistent, Well, I'm going to say double D, and I'm going to say 75% of his points scored. Whoops, that's a C. 75% of his points scored is greater than any other teammate. Okay, 75% of the time his scoring is better than anybody else. I mean, look, it's greater than Leaping Larry's maximum. It's greater than the vast majority of Wilt, Stilt, and Giant Jimmy. He scores 25% of the time there, but he scores nothing up here. Bigfoot, okay, he's 75% is this much, but Duncan Dave, besides this outlier, his minimum is greater than Bigfoot's first quartile. Okay, with 2 minutes to go in the fourth quarter, the score is tied. Of the 6 players shown, who would you not put in the game? Okay, I am not going to put in Leaping Larry because, again, of his ability to not score. Now, you could also say Steve Sky. I could live with that. Excuse me, but Steve Sky every once in a while scores a lot of points. Wilt Stilt would be good because he every once in a while gets us a lot of points. But if you look again, if we compare Leaping Larry with Wilt Stilt, besides the one outlier, all of his numbers, his minimum is greater than the first quartile of Leaping Larry's. 75% of Leaping Larry's scores are below or close to being below the first quartile of his teammates. So Leaping Larry okay, and his lower 75% is less than most of his teammates scoring. Don't use the word average anywhere in here because this is not their average scoring. This is the points scored during the year. This is not his average. So your answer for A and B should have nothing to do with average. So Leaping Larry, since 75% of his scoring is below his teammates, is less than. Okay, So there are those. So what I did on your exam is if you answered the 10 multiple choice questions, you got 10 points. And then I added 1 point for each one you got correct. And then these were worth 5 points each. You had to name me a player that made sense and then give me a good explanation. If you just named a player, I think I gave you 2 points for each one. At least you read the thing and looked at it and made some kind of effort. But this was worth 30 total points. Have a good rest of the day.